Hello everyone, welcome to this tutorial. So in this tutorial I'll be covering what GIS is, and we're going to also be using QGIS for an exercise. So what is GIS? GIS is a system that's designed to capture, store, manipulate, analyze, manage and present spatial or geographic data. GIS is not a specific software, rather than it's in a system or an approach to manage spatial data essentially. A lot of people get GIS confused, they think it means software, but as we're going to show here, you can see that there's different packages for GIS. So for example, Google Maps, as you can see here on the left, uses a GIS system to manage the spatial data, so we know where everything is in a kind of virtual world environment. And we see other software like QGIS, which helps us kind of do more analysis and manipulate our own GIS datasets. And there's a really long list of other GIS software. Some of them use syntax coding like Python and R. So GIS, in a sense, tries to represent the real world through layers. Or aspects of the real world. So sometimes it can be some kind of an abstract. So if we're looking at poverty, we use GIS methods to kind of represent those abstractly as well. So you can see here on the bottom we have the real world, and basically in GIS what we do is we create layers, and each of those layers contain similar information. So we have population, communication networks, hydrology, land use, etc. So this data set of the real world will combine all these different layers of information. So there's two types of information. There's spatial and non-spatial GIS data. So non-spatial data are data that do not contain any geographical reference to position, whereas GIS data contains both types of data. So non-spatial data, this will include, for example, a typical spreadsheet where it doesn't have an explicit reference to a real-world position, using a geographical reference point. GIS data is something referenced in space through a longitude and a latitude, for example, or a coordinate system. And as you can see to the left here, we have GIS urban topography data set, and those kind of shapes represent kind of something related to the real world. Yeah. And each one of those polygons, points or lines have certain information attached to it. So a line, for example, a road might have a direction, the classification of a road in terms of whether it's a highway or just a street, and for example might have a speed limit. So those things are not necessarily spatial, but they're attached to a spatial object in a GIS system. And when we get into QGIS tutorial, this will become clearer. So we have a few things to consider when we're working with GIS. First thing is map projection. So as we know, the Earth resembles a spherical kind of shape. So when it comes to kind of viewing information spatially, we need to project this spherical shape into some kind of flat plane for us to understand it, essentially. And this is where we use something called map projections. So, and the most common ones are the EPS-SG 27700, which is called British Grid, and the one that Google Maps uses is typically 4326, also called the Mercator. And you can see here to the right, there's different kinds of projections. So you can project something in a cylinder. You can project the globe in a cylinder way, or a conical way, or a planar way as well. And a coordinate reference system, what it does is it works with the map projection together to reference an object on a sphere. So you can see here latitude and longitude is an example of a coordinate system. So a coordinate system will locate something in the real world, and then it will project, that coordinate system will be projected on our map projections here. So then we can translate something in 3D. So let's say we're looking at Manchester here. where it will be kind of -2 and 53 longitude and latitude. And then we project it onto a 2D plane, and this will be a grid as well, corresponding to the same grid that we have here. So we have two types of GIS data. We have raster and vector, similar to the differentiation in Photoshop and Illustrator. So raster will be image data. So this is something, for example, would be an image taken of the city from remote sensing. And vector data are represented in points, lines, and polygons. And they don't have a resolution, whereas raster models work in cells. As you can see here, so on the left we have a vector kind of features, and on the right we have raster features. So points in a raster feature will just occupy one cell. In a vector feature, however, lines will be one continuous object. However, in the raster feature, again, they'll occupy cells, but they're not distinct as one single line. Rather, you need to interpret them as a series of cells to understand them as lines. And we can see here with polygons as well, each one of these are different and independent, whereas the raster they're represented as cells again. So there's no inherent differentiation here. It's just the value of a cell, whereas here every one of these objects is different. And one of the main things when we're working with GIS is using layers, as mentioned earlier. So it's a way for us to manage a system. So if we're looking at a topographical kind of data set, we'll have streets on a different layer, buildings on a different layer. These might be represented as a line data set. This might be represented as a point or polygon data set, and these might be represented as a polygon data set. So we can have different forms of data sets, but all together will give us kind of an integrated data set like this. So an early example of GIS, this is a very popular example. So in 1984, John Snow was exploring the issue of a cholera outbreak in London, and he had a hypothesis that these cholera outbreaks, they're not just random. At the time, it was assumed that maybe it's pollution that's causing this outbreak. But what John Snow did was map these outbreaks. As you can see here, they're represented in black dots. He saw that they were concentrated around a single area, and then he noticed that there was a water pump. You can see just over here, right in the center of this outbreak. So he hypothesized that the cause of this outbreak is because there's a contamination in that water pump. So once they figured that out, they closed the water pump. The cholera outbreak got reduced. So again, John Snow employed a system of managing spatial data and mapping them, and then through that approach, he gained a better understanding of what's happened, and they can understand the problem a bit better. Again, this is not any software, but he's using a GIS system in the definition of a system to use, store, and analyze spatial data. You can also use this for research. So this example of a master's research at the MSA, where spatial history was explored. So this is in the city of Tripoli in Libya. So by looking at different historical master plans of the city and different land uses from different years, you can kind of build a picture of how the city changed and how the master plans informed the development of the city. So you can see here the different stages of the development, and all this is traced through digitizing archival material and then mapping them together. And then you can build a narrative and a picture of how things have changed over time. So thank you. What we'll do next is I want to show you how to use GIS in QGIS. So QGIS is a popular open source GIS software. You can download it for free. So please download the software. So in the next video, I'll go over the interface, and the video after that we'll go into a quick exercise. Thank you.